Meet hands-on, a student ready for a day of learning and getting ready for the class. But sometimes, the best lessons happen when we least expect them.
Well, start back at the very beginning. The origin of mathematics lies in counting. In fact, counting is not just a human trait. Other animals are able to count as well, and evidence for human counting goes back to prehistoric times with checkmark made in bones. There was several innovation over the years, with the Egyptian having the first equation, the ancient Greek making strikes, and many areas like geometry, numerology, and negative numbers were invented in China. And zero as a number was first used in India. Then, in the golden age of Islam, Persian mathematician made further strides and the first book in algebra was written. Then mathematics boomed in the Renaissance along with the sciences. Now, there is a lot more to the history of mathematics than what I have just said.
A major part of any ancient science was mathematics. It's difficult to tell how mathematics were used by the different Bronze Age culture, as math could have just been done mentally, leaving no proof or procedure. This means the only evidence for math we can find are from civilization with writing system.
We would like to discuss the ideas of integral and differential calculus, which has been developed separately a long time ago with these two stunning men, which is Newton and Leibniz. Isaac Newton was born exactly on Christmas, and his father died before he was born. His mother left him because she met a richest guy, but his dream never ends there. He went to college to study and reach his dream. He used all of his experiences to motivate himself and not giving up. He created telescope and he loved reading. And while he's reading, an apple fell into his head, and that's the beginning of gravitational law. But there's more. While he's solving the equation of an area, he discovered a two-functional equation that can be used in the future, and that's exactly the beginning of calculus.
In the annals of history, there are few rivalries as captivating and impactful as Isaac Newton and Gottfried Wilhelm Leibniz. These two brilliant minds sparked a revolution that forever changed the course of mathematics. Isaac Newton, an English mathematician and physicist with an insatiable curiosity, Newton's groundbreaking work in physics and mathematics laid the foundation for the development of calculus. Gottfried Wilhelm Leibniz, a German philosopher, mathematician, and polymath, Leibniz independently discovered calculus, driven by his deep fascination with the nature of mathematics and its application. Newton's approach focused on functions and infinitesimal differences, while Leibniz introduced the now familiar notation of derivatives and integrals. Their facts were bound to a cross, and when they did spark flew the question of who truly deserved credit for the development of calculus became a fierce battle that spanned years. The dispute escalated as accusations of plagiarism and priority filled the air. Scholars and societies took side, fueling the flames of controversy. Despite the bitter feud, both Newton and Leibniz's contributions were profound. Calculus revolutionized mathematics, providing a powerful tool for solving problems in physics, engineering, and countless other fields.
Calculus is utilized practically everywhere. Since integrals describe the total of almost anything and derivatives reflect the rate of change of things, calculus has a wide range of applications in physics. When you combine this, you can discuss a broad range of subjects. Calculus makes it simple to determine an object's area or volume. When examining difficult-to-measure shapes, this is helpful. Calculus is also used in statistics. Calculus is used in a variety of scientific fields, including commerce, meteorology, computer science, engineering, medicine, pharmacology, space exploration, and telecommunications. Calculus is used in space exploration to determine an object's position, velocity, and acceleration. Calculus, for example, is used to determine the ideal trajectory that will allow a spaceship to reach its target while spending the least amount of fuel. Because music is merely a function, calculus is important in the field. Calculus can assist company managers in maximizing profits and calculating the rate at which earnings increase with each increase in production by calculating marginal revenues and costs. Calculus concepts serve as the foundation for artificial intelligence algorithms, such as neural networks.
Just like us, understanding calculus comes with challenges. Remember, every challenge is an opportunity for growth. Each problem you solve is like leveling up in a game. Embrace the struggle because it's a sign that you're pushing your limits and expanding your understanding. The skill you gain from conquering these challenges will not only help you in a math, but also in approaching and solving problems in all areas of life. So, keep pushing forward and celebrate your victories along the way. Because success is the sweetest when you've conquered the challenges. Our journey through the history of calculus may be over, but the learning never stops.